Hey everybody, this is your video for the 5-3 Math Excel. So on the first one it says find an equation in the form y equal ax squared plus bx plus c for the parabola passing through these 3 points. So what they're having you do is they're substituting the number negative 156 for y. They're plugging in 6 for x in 2 places. So that's the first point. For the second point, they plug in negative 30 for y and 3 for x. And for the last one, they plug in negative 2 for y and negative 1 for x, again in 2 places. So then what they do is you do 6 squared is 36, b times 6 is 6b, and then just say plus c equal that number. And then do the same thing here, 3 squared is 9, and so forth. So now, when you have this, the view and example shows a much longer way to do it. The shortcut would have been just use your methods that you've learned about solving equations. When you're using RF, you can solve equations. You don't have to necessarily do substitution or elimination, all these different combinations they're showing you in the view and example. So you're able to do RF and type in, the coefficients, the 36, the 6, the 1, the negative 156, and so forth. Remember, if there's no number in front, you put 1. And when you do that, you get this matrix. And you know it worked if you get the 100, 0, 10, 0, 0, 1. And then this part would actually be your answer. So you have the negative 5, 3, and 6. Now, what that means is that A is negative 5, B is 3, and C is 6. So your regular equation, like we've said before, is y equal ax squared plus bx plus c. And so then you just put the negative 5 in front, so you have negative 5x squared, then plus 3x, and then plus 6. And so that's how you get it. Now, even though that is quicker than the view and example, there's an even better way. Okay, so the better way would be go to New Document. I'll show you the steps in a moment, but I want to talk through it first. Go to New Document, then List and Spreadsheet. Then you're going to put X and Y on top, and then you put your points. These are your X's, these are your Y's. Then go over to cell D1, and you've used linreg before for linear regression. In this case, you want quadreg for quadratic regression. And then just choose your XY because that's what you named it up here. And when you do that, it gives you your answer, negative 536, and it says r squared is 1. Now underneath that it says RES ID, like residual ID or something like that. You just want to ignore that. It says 1.8 e to the negative 12. Just as a reminder, if it's e to a negative number, you're going to think of that as 0 because negative means it's left. So you're going to have 0.00, a bunch of zeros, then 18. So if it's e to a negative number, that's going to be 0. So e to a negative number is 0. Now, comparing that, e to a positive number could be infinity. Like if it's e to the 200th or e to the 500th or whatever, then you're going to get a huge number, and so e to a positive number could be infinity. Okay, so again, you get your negative 536, and so that goes in front like this, negative 5x squared plus 3x plus 6. Okay, so that's the steps. Now let me actually show you that. So you have your calculator. I'm going to do new document and don't save it. This is where you do number 4, which is list and spreadsheet. List and spreadsheet. And up here in the A part you put X, and then here you put Y. You're able to put words there if you want instead, like time and height or whatever you want, but I usually just put X and Y. And then I go 6, 3, -1, those are all my X's, and then -156, -30, and -2. So those are my Y's. So when you have that, then I like to go over here to the side where I don't overwrite my data. I go to D1, it's column D, row 1. So right there, I do menu, 4 is statistics, 1 is stat calculations. Now, before we use 3, which is linear regression, but here you want to use 6, which is quadratic regression. So let me write this down. You go to D1 and you're doing quadratic regression. So that would be menu, 4, and then 1 for stat calculations, and then 6 for quadratic regression. So menu 4, 1, 6. 4 with statistics. Okay, so when you do statistics and then stat calculations and then number 6, this is where you either go to the right and choose your variable, or you could have just typed X. I'm just going to type Y for that. So right there, then you just scroll down, press OK, and there's your answer. So many problems can be solved using quadratic. So this would be a really easy method to get your answer. This is used for modeling your data. So the A is the coefficient in front of the x squared. The B is the coefficient in front of x. Now when I went to that, you can see it a little bit better here. A is the coefficient in front of x squared, B is the coefficient in front of x, and C is the number by itself. And then if you scroll down, R squared was 1, which means it worked. And then residual, that's the one we don't really care about. So again, the A, B, and C are what you want to focus on. And so again, we got the same answer, both methods. Okay, on your next one, you're given 3 points and you want to write the equation. So again, just use quadratic. And same thing on the third one. Now on the next one, number 4, it says, a man throws the ball off the top of a building and records the height of the ball at different times. Find a quadratic model for the data. So you have your time in seconds and your height in feet, and then you have your table. So again, I would use quadratic and get your equation. That's going to be the best method, in my opinion. If you'd like to use a different method, you can, but I'd use quadratic. As long as, it's like using your numbers, not using Mathway or something you shouldn't. So now the next part says, use the model to estimate the height at 2.5 seconds. So then you go negative 16.5 times 2.5 squared plus 34 times 2.5 plus 48. And when you do that, you get 31.1, so that means 31.1 feet. The next part says, what is the ball's maximum height? Now, in the view and example, it says basically to make a table at every 0.5 seconds. I don't really care for that method. The other method would be graph it. And when we graph it, then you can actually determine the max, even if it's not at a half interval, basically. So if I go to a graph, I'm going to go negative 16.5 x squared plus 34.5x plus 48. Now, we're looking for the maximum, which is the highest part, and so you have to do zoom fit, menu 4A, so that's up here, and then we have to find the maximum. So you go to menu, analyze, and then maximum is 3. And then you go between here and here. So that tells me 1.045. I'm just going to round to a few places to 3, and then 66.034. Okay, so that's what I got. And then apparently they just wanted a whole number answer, and so 66.034 as a whole number would just be 66. So I think it's a coincidence that it's here, because it could have been at half a second or 1.5 seconds or whatever, but in my case that was the answer. So basically think of dropping the ball, it hits the ground, bounces back up higher than it was, so that's why this number is usually going to be higher, than the original, higher than the 48. Now on subsequent bounces, it's going to get lower and lower. So it's usually going to be one of the first couple of seconds, or half seconds, or third of a second, whatever. All right, so that's how you do number 4. On number 5, it says determine whether a quadratic model exists for the set of values, and it gives you f of 0 is 3, f of 4 is 35, and f of negative 2 is 23. Well, all this is a different representation of the ordered pairs. So remember, it's f of x equal y, and so these inside the parentheses are your x's, and these to the side are your y's. And so then you can recognize, oh, I'm going to do quadratic and get my answer. Okay, the next one says the table and graph give stopping distances of an automobile for dry and wet conditions. So in the table, it has your speed and stopping distance on dry roads, and this is your data. Then to the side, it says the graph is for wet roads. So there are two different sets of data. The graph that's given is not for the dry roads. It's labeled as wet. And so then use your graph to find points. If you need to expand the graph and open it a little bit better, you can. When I did that, I saw 0, 0, which was the origin, 20, 50, so x 20, y 50, because it was like, I think on mine it said something like each tick mark was like 50 extra, and then each x was like 10. So I just figured it out what my points were. Then the next part is you have to use quadrag for both for part A. So do quadrag for this set of data, and get an answer, and write it down. Then do quadrag for this, and get an answer and write it down. So you'll probably have to start a new document for each because this has 5 points and this just had 3. So start a new list sheet for the second one. And that will give you your 2 answers for part A because the 2 answers are the 2 equations. So just do like we did before. Then the next part says use your models to compare for 65 miles per hour on dry and wet roads. So what you do is you take your 2 equations which you were given, which you found, and plug in 65 for x into both of them. So like as an example, you'd have to plug it in 2 places. Plug 65 into 2 places for each equation. Since it's basically y equal ax squared plus bx plus c. So you have to plug it in there and there for each one. Alright, then the next one says extra practice A, find a quadratic model given 3 points, and so again you use quadratic for that. Then for your last question, on your last question it says a player throws a basketball toward a hoop. The basketball follows a parabolic path that can be modeled by the equation given. The table models the parabolic path of another basketball thrown from somewhere else on the court. If the center of the hoop is at 2011, will each ball pass through the hoop? So for this one, your ordered pair is 2011, so you plug 11 for y and 20 for x in the 2 places. In this case, you get 11 equal 11, and so that would be true. So that's from the one where you were given an equation. For the second equation, it says it's another basketball thrown from somewhere else on the court. And they give you a table. And so for this table, you have to use quadrag again, and then use 20, 11. So we put 11 for y and 20 for x in 2 places. In this case, we get 11 equal 2, so that's false, which means the ball is not going to go through the hoop. And so then I have my little explanation here. The ball is not going to pass through the hoop, which means you could have a different shooting motion or arc. And this shows how quadratic equations can be used on video games like NBA 2K for different players with different release points. The arc could be different, the height of the players could be different, and so depending on how realistic they're making it, they could have different equations for different players. Alright, so that's going to be the end of that video for your Math Excel.